whole unit deals with area figures. We're going to talk, as you guys can see here, about 6 different figures and finding the area. The last unit we do after this one's on surface area and volume, where we go to 3-dimensional figures like spheres, prisms, pyramids. All right, so this one's just 2-dimensional area of parallelogram circles. You guys can read through all 6 that are up there, which means every figure comes with a formula how to find its area. So I know I've seen a lot of index cards out there, Quizlet being used to study purposes. Definitely keep track of these formulas, because I hate to break it to you, I am not going to give you every formula. I think I'm only going to give you 3, and the three I give you are probably the easiest to remember. All right. So what I want to do with you now, before we start, because every day is dedicated to certain figures, let's go through all the area formulas now, so I don't have to review them when the day comes. So parallelogram is the first one. All right, area of a parallelogram, a figure we are familiar with in this class. Area of a parallelogram, base times height. Base times height. BH, base times height. I need to get you out of this middle school mentality, which is right now you hear the word base and you see a figure, you automatically look and assume I'm talking about the bottom. No, that is not the case. Anytime I talk about a figure and its base, it could be any side. A base could be any side of a figure. So what I'm going to show you here right now, I'm going to put the base up here. That could be the base of the parallelogram, even though it's on top. What the important piece is, the height has to be drawn to the base. All right, so when I say base times height, this height needs to be drawn to the base. All right, so height always drawn to whatever we're considering the base. Now, just a height. I think I gave you I don't want to say it's a better word, but a different word this year. For this segment here, I just drew up that's perpendicular to the opposite side. We only did it in triangles, but it could be found in any figure. Starts from a vertice perpendicular to the opposite side. Doyle, that's an altitude. Good man, that's an altitude. All right, height, altitude, same thing. So everyone good. Base does not automatically equal bottom, but the height will always be drawn to your base. Leave that, please. I want you to take a look at how I'm going to change things up here. Leave your diagram, please. Leave your diagram. I'm going to put the base on the bottom here now. The height isn't where I just drew it. Now the height would be coming from this vertice, actually on the outside of the parallelogram, drawn down. So there's the height. Right? The base is always drawn. The height is always drawn to the base. All good? All right, next one. I think you guys might be familiar with this one. Circle. And you guys don't have to draw a circle in this one. Circle, anybody know that one? Pi, r squared, yes. And I know we just finished a month of this unit. R for radius length. Okay, I don't need to write that in. So pi times the radius length squared. Triangle. That's one you might be familiar with. Triangle? No? 1/2 base times height. Yep. So 1/2 base times height. Again, it doesn't mean the bottom of the darn triangle. It could be any side, wherever the height is drawn to. What I would like you to draw in this one for triangle, can you draw me a right triangle in that box with triangle formula, with the triangle formula? All right, anytime you're involving a right triangle and finding the area, base and height of a right triangle, base and height, 2 legs. Okay, the base and the height of a right triangle are the 2 legs. So just keep that in mind, because we will be dealing with a lot of right triangles. Parallelogram, circle, triangle. I did those 3 with you for a purpose, for a reason. Star them for me. I did those 3 first because those are the 3 I'm going to give you. Right? These are on the reference sheet. Now, we haven't used this reference sheet. That's awful spelling right there. One job. So this is on the reference sheet. We haven't used the reference sheet much other than quadratic formula, but I did attach it to the back of your packet. So please just turn your packet right around. It's on the very last page. Everyone see the first three on the left-hand side: triangle, parallelogram, circle. All right, you have those available to you on the test next Tuesday. The rest I go over now are on you. All right, everyone good? Again, I told you, they're always the easiest ones to remember they give you for some reason. All right, rectangle. Some people use, base times height. I use length times width. That's what I use, length times width for the area. Trapezoid, a little bit more involved than these four, but 1/2 the height of a trapezoid. I take 1/2 its height, and then I multiply that with the two bases that are parallel to each other, B1, base 1, plus B2, base 2. I add the bases together, multiply the height, and take 1/2 of that. And again, why don't you draw a trapezoid in that one, just so we are all clear on what I mean by B1, B2, and the height. All right, remember trapezoid property, one pair of opposite sides parallel. Those are your bases again. That's B1 and B2, whatever the parallel sides are. And the height comes from one of the vertices. All right, I'll do the one inside here. Here you go. There's your height. All right, there's the height. So the bases are the parallel sides, height drawn perpendicular from a vertex. And the final figure we'll do here in this unit is a rhombus. I wrote in kite because they have the same formulas, but we actually won't do kite in here. We'll just stick with the rhombus, but same formulas. There's that 1/2 again. I want to see if anybody knows what I mean by the following variables here. D1 times D2. What in the world could I mean that would represent D1 and D2 that's in a rhombus? That's in a rhombus. Matt?
Diameter.
Diameter, that's a circle.
Oh, I thought, are they not rhombuses too?
Diameters? I think you meant another word though. You're thinking it, but you called it a diameter.
Diagonal.
Yeah, there we go.
I was thinking diameter, but
Diagonal length. Yep, you're good. And there's two in a rhombus, never congruent. That's a rectangle. Two diagonals in a rhombus, different lengths. But that's tomorrow. All right, so those are the 6 we're going to cover. Any questions? What's today's focus? Parallelogram triangle, and I add a little circle rectangle in at the end. But our focus today is parallelogram and triangle. All right, let's do this. First one up, parallelogram. Find the perimeter and the area. I'm going to start with the area first, kids. I want to find the area of this one. So the area, we know the formula, base times height, always on the formula sheet if you need it. Notice I gave you 3 values, 3 lengths. 2 out of the 3 are the base and the height. Which one are you confident in right now? Give me one that you are, forgot the mug shots. Give me one that you are confident in. And where does it go? Give me one that you're confident in, and where does it go? Shoom, Doyle, Aiden, sorry. Oof, I had it right in front of me. Give me one you're confident in, Aiden. Height is 24. That's what everyone's confident in. Yep, 24. Now the question is, where's the base? Right? Is it the 7 or is it the 23? Come on now. The base has to be on the darn figure, right? The base has to be, it's part of the figure. So the base in this case, 7 or 23 is going to be, Matt? 23, yeah. And again, everyone remember what I said. Height drawn to the base. So there's 23. And it's not bad news, but I have to change my philosophy right now. My philosophy all year long has been, I do not care if you put units or not. I don't. Until we get to this one. No pun intended, until we get to this unit. All right, why? Because we're going to go from lengths of segments, perimeter, to area, which is now a different beast. We all get 552 feet square feet when you're talking about area. So I am going to require you to put units on all your answers now, because I need to know you know the difference between area versus a perimeter versus a side length. All right, those are labeled differently. All right, now let's go to the perimeter of this bad boy. I see one side is 23. It's a parallelogram. So what else do we know about one of the other sides? Well, the other side is 23. Not all four, but at least opposite side is 23. Now we need to find the other two sides, which we know are congruent. All right, look at my diagram and what I gave to you. And it seems like we use this every unit, don't we? What still needs to be used here to find the other two sides? Going deep, Gabby. Pythag, great job. I gave you guys a right triangle over there. So 24 squared plus 7 squared equals c squared. And we're getting 25 out for that side. So plus 25 plus 25 gives me 96, but be careful here. This is why I want units. So you could show me you know the difference here. 96, do I square the feet here? Nope, it's just 96 feet. The only thing that gets squared is when you find the area. Also included in this unit is not all these formulas, but we got to do a little review, because you can see what type of triangle is coming back, huh? All right, we need to do a little review of our special right triangles, but before we do that, we're just finding the area. No perimeter on these two. No perimeter, just area. What's one value I can plug into the formula based on this parallelogram? What's one value? Going back here, Matt. What's one value I can plug in? 17. What is it? The base or the height? Base. Oh. You mean I can have it on top? Yeah, you can. Okay. Because if that's 17, that's 17. There's my height. All right, everyone ready to find the height? Let's review, because you guys see this is a 45, 45, 90 triangle. Let's review our rules. In a 45, 45, 90 triangle, there are two legs, both of which, what do we know about those two legs? Legs are congruent. The sides across from the 45 are congruent. Legs are 45, huh? Legs are congruent. And then we also have a hypotenuse in the 45, 45, 90. Ooh, anybody remember that rule, Zeev?
Is it leg times radical 2?
Radical 2 it is, yes. So I have the hypotenuse, leg times radical 2. Just want to review that with you because it's on the assignment, and I'm sure it'll be on the test in a couple weeks. All right, let's go back up to our parallelogram. Notice the 9 I gave you is across from one of the 45s, and the height is across from the other. All right, what's the height then? 8, Josh? 9. Also 9. There it is. Legs are congruent. So we have 17 times 9. I'm not even going to ask anybody. 153 square yards. Make sure it's squared. Units, units, units. And if we're going to give love to 45, 45, we got to give a little love to 30, 60, 90, right? All right, let's start here again. Base times height. And now it's 32 for the base. And let's find the height now. All right, 30, 60, 90 rules. Again, 30, 60, 90 rules. Are the legs congruent anymore? Nope, but we did call one the shorter one, which is across from what angle? the shorter leg always across from the smaller angle, 30. And then the other leg, it's across from 60, we called the longer leg. And we had a way to find the longer leg. Anybody with that one? You take your shorter leg and multiply it by, that's coming up. That's hypotenuse. Longer leg is shorter leg times radical 3, yep. And then hypotenuse, yes, to find the hypotenuse in a 30, 60, 90, you take your shorter leg and double it, multiply it by 2. Okay, so just a review of the rules. You're going to need them tonight and going forward. This isn't the only day we're going to see 30, 60, 45, 45. All right, let's go back up to the parallelogram. What's the 12? Hypotenuse, shorter or longer? Shorter. And looks like the height is the longer leg. So the shorter leg is 12, and I'm looking for the longer leg. The shorter leg is 12, looking for the longer leg. All right, using our rules now. Using the rules, how about that longer leg? Josh?
12 radical 3.
Yep. So 12 square root of 3. Good job. And now you guys can multiply and round. Because I'm asking for nearest 10. I'm not going to ask anybody. 665.1 meters squared. Quick comment before we head over to triangles. Quick comment here. Is it required that you guys know these? No, there's another way around it. Anybody else? How else could I have found these values without knowing anything from 30, 60, or 45, 45? Josh? Sine, cosine, tangent. SOHCAHTOA. Okay, you could have used those. We are actually, I'm not going to go through and do it because we're going to actually review it tomorrow in our notes, but you could also use sine, cosine, tangent. Just make sure whatever NumWorks calculator you're using, whether it be the one you're using in class or on your phone or the app on the Chromebook, make sure you're in degree mode, remember. All right, using sine, cosine, tangent, make sure you're in degree mode. All right, so we go from parallelograms to triangles and making an appearance in our notes now. Usually it just makes an appearance in the quizzes and tests. Our boy Big Al. Yep, Big Al. Okay, I'll move on. He owns of course he does, a triangular plot of land. Of course he owns a triangular plot of land. And then he buys another triangular plot of land that he's going to add on to his first one. What's the area of the whole thing? Triangle ACD. All right, so I look at triangle ACD. Hey, just watch yourself here. Here's where I worry about. We just spent the last 10 minutes doing base times height, base times height, base times height, base times height. Triangle now. What do you got to make sure you add in? Whoop, 1/2 base times height. All right, be careful. And plus, it's right in front of your face on a formula sheet. Can't get it wrong. Can't get it wrong. And not only am I going to have you guys find the area of a triangle, what type of triangle am I going to have you find the area of? That's pretty anticlimactic. Thank you. A right triangle. Yes, good job, everyone. Good job. Don't everyone yell at once. That is a right triangle. We just got done talking at the beginning of class. Right triangle, base and height are automatically the two. You walk with them. There you go. Legs. Yep. I thought I gave a good clue there. Are the two legs. So 1/2, 15 times the other leg, AC. Need your help finding AC now. Okay, need your help finding AC. Can you give me a plan on how to find AC here? Whew, there we go. Back. I'm just stalling. Zeev. On which triangle?
ADB.
Good. Let's do pi fag on ADB and then add 16 to it. All right, I get a little nervous when you do pi fag with this type of values. So let me just ask somebody so I'm confident in you. Olivia, here you go. Where should the 15 go into? Yeah, sure. And how about the 25? There, good. Just want to make sure we put the 25 for the hypotenuse. C. Thanks, Olivia. And make sure this is not getting plugged into our formula. I need to add 16 to it before I do. Whew. Looking like a nice day out there. That's all I gotta say. None of that new rain that's been creeping around, kids, huh? You guys don't want to talk. I don't care. I'll just be as annoying as I possibly can be. Everyone getting 20. Not what I want to plug in. Add 16 to it. And trust me, I am good at being annoying. I got a lot of practice. So that's going to be what? 270 units, square yards. And next one. Oh, Big Al, at it again. Not only does he have a garden that's in the shape of a rectangle, but it's also in a rectangular backyard. Big Al is a genius. All right, what's the area of his garden? Whoa, garden's a rectangle. So length times width, base times height, whatever you float your boat, find your lost remote. I know one side of that rectangle is 6, so we can plug that in. I'm going to need your help, though, kids. How can I find the other side of the rectangle and multiply with 6? I need a plan of action, please. Talk to me here. Gabby, talk to me. How can I find that other side here?
Well, it's like 10 and 25 of the legs of that triangle.
Okay, and what are you going to do here? Okay, that's all I wanted to hear. That's all I wanted to hear, and I'll tell you why. Because your class, I'm going to make life difficult on your classmates here. Gabby just said use Pythag. I got a problem with that. I've been in this class a long time here, over 30 weeks. And I've been told every time Pythag can only be used in a right triangle. How do I know that's right? And the answer is not, because it looks like a right angle. That's what I hear when some of you talk. How do I know that's going to be a right angle? Doyle? Darn right, because Doyle knows his rectangle properties. And there's right angles. And Gabby kind of gave this away, but I want to repeat it. I have no sides in this right triangle right now, none. So how can I do Pythag? I at least need 2 out of 3 sides. Gabby could subtract. That's how she did. She can subtract. Believe it or not, that's how you got into honors, right? 40 minus 15, 25. Not like me. I got kicked out because I couldn't do long division. 80 to, I'm still bitter. 80 minus 70, we get 10. And yep, we do a little Pythagorean theorem. 25 squared plus 10 squared equals c squared. And something's happening now that hasn't happened yet when we did Pythag. It's not a perfect square. Everyone's taking the square root and you're not getting a whole number. Okay, so you're getting 5 radical 29. Fine. There you go. There's the other side. Plug it in. 5 radical 29. And now we're rounding it to the nearest foot, square foot. I just want to make sure you're good there. How's our rounding doing? Gianna, how's our rounding doing? What are you rounding this bad boy to? 162. Good job. Feet squared. Whew. All good. One more topic. All right, so we did the areas of all these figures. Something else that's associated with area. I didn't need, I don't have time for this today. I don't have time for this.
Slide left, slide right.
I will have so much great things to do with you.
Shatter.
I wish you knew some of your circle facts and stuff as much as you did these.
Genie. Curtains. Clock.
15. 16.
Spin.
17. I think we're good, right? Oh, well, I'm good. Cube. Slide left. Slide right. Stars. Shatter. Flip, wipe. Sorry, wipe. Drop. Genie. Swing. Pinwheel. Fade. Curtains. Clock. Curl. Book. Flip. Spin. Okay, fine. I'll give you both. Sure. Shatter, book, Promethean person. You ready? Shatter, book, Promethean person. Shatter, book, Promethean person. Ooh, pinwheels. 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 Nobody with the pinwheels there. Sorry, kids. Sorry. That's not shatter, by the way. You know that. I know some of you are going to argue with me. All right, here we go. Population density. All right, this is a term you haven't heard of. I have the definition up there, but it doesn't mean much. Let me show you. Don't draw anything. I just want to show you. Say I have this piece of land right here. There's my piece of land. Actually, let me make it a little smaller. Here's my piece of land. Ready? Here's what I'm going to do in the land. I don't know what those little curves are. They're all supposed to be dots. Very high population density here. Very high population density. Versus much bigger land, right? So everyone's going to assume a higher population density. No. This population density is much lower than this one, even though the size of the land was bigger. It's how much you can pack into a region is a population density. All right. It doesn't matter the number of people, doesn't matter the number of size. It's all relative to how big the land is and how many people you put in. So this example here has a higher population density than this one. All good? How do you calculate it now? How do you calculate population density? There's just like everything in this unit, there's a formula. You take the population divided by the land area. The population divided by the land area. So the best example I could find out just to introduce this to you guys is I took the 5 boroughs in New York City. And I want to know which one has the highest and which one has the lowest population density. And you just can't look at the table. You can't just say, oh, look, Queens has the biggest area, so it's going to have the highest population density. Not necessarily. Depends on how many people you're packing in there. All right, so let's calculate the population density for each of them. I'll start out with Brooklyn with you, and then you can find the other 4 boroughs. So population density of Brooklyn. I take its population, which is about 2.4 million people in Brooklyn. I divide it by the area of Brooklyn, which is 70.61 square miles. Divide those two. I get this number out. 34,914, and I'm going to put the decimals too because I don't know how close some of these densities are going to be. That's great that you find it, but darn it, you're in honors math, and I want you to understand what it means. So everyone got almost about 35,000, right? So here's what that means. Don't find the other boroughs. Just let me explain what this means. Everyone's familiar with the Post-it note? This is my best way to explain this. Everyone's familiar with the Post-it note. Well, pretend this is a giant size Post-it note that is 1 mile by 1 mile. Huge Post-it note. In Brooklyn, there's going to be about 35,000 people that could fit in there. All right, about 35,000 people that could fit into this 1 by 1 mile Post-it note. All right, now is that the highest amount I could fit in there? Find the other 4 boroughs. Go ahead and now calculate the population density of the other 4 boroughs. Okay, you guys are noticing, yeah, there's more people in Manhattan that pack in that Post-it note, huh? All right, Manhattan's got the highest population density. Actually, there's almost double the amount of people that would be in this 1x1 square than in Brooklyn. And then the smallest one, Staten Island. It would have the lowest number of people in that Post-it note. All right, let's play a little game real quick before we go to the last example. Let's play a little game because I need to make sure you understand this concept of population density. Let's go to the 5 boroughs in New York City to states, 50 states in the United States, right? 50 nominations. So I understand, you show me you understand here. Nominations for the state with the highest population density. And remember what population density is, right? A lot of people packed in to a space. Doesn't matter the size of the space. A lot of people packed in there, though. All right. I've done this already. So POP, there it is. Rate by states. Pop. There we go. All right. So what do we got? Top one. Nominations. Doyle. California. Big state. Now it's a matter of how many people are in there, right? Because if there's a ton of people in there, automatically it's going to blow anything out of the water. But it depends on its population. Matt.
New York.
New state we live in, right? Not that big of a state, but we just saw in New York City, a ton of people. All right, could be New York, California, other nominations. Go ahead, Matt. Florida, all right, yeah. You think a lot of people live down there. It's a pretty decent sized state. Doyle?
New Jersey.
New Jersey. All right, New Jersey. All right. Is there a lot of people there? If there are, that's a small state, and that'd be a high population density. Doyle, you going to keep rolling?
Illinois.
Illinois. Why'd you pick Illinois?
Chicago.
Oh, all right, yeah, all right. I didn't even think about that. Yeah. Populous city. Others? Nothing else? It has been said. Okay, it has been said. So here you go. The state with the highest population density. Delaware. That has not been the answer the entire time.
Isn't that a city?
Delaware?
That is geography. Okay.
We'll pretend that I didn't hear that. It's never been Delaware.
It's Delaware right now.
New Jersey. Delaware is number 6. This is for 2020 population data from the year 2023, so most recent here. But New Jersey. All right, I don't know why that was, but New Jersey. All right. And then you'll notice all the other states that are below it that aren't, territories are all East Coast states, right? Smaller states, but a ton of people packed in. All right, and then, you got Florida here is number 7. There's New York, 8. Can we go down the other side of the list? Lowest population density. Will? Montana, huge state, right? What, just cows live there? No, I'm sure there's people that live there, but Josh? Alaska, another huge state. I don't know. How many people are there? Doyle? Wyoming. Now we're going out west now, huh? Any others? Yes, Will? Arizona. New Mexico. You guys are right around each other, right? All right, so the answer has been said. Going down, it is Alaska. All right, but hey, notice Wyoming, Montana, the Dakotas, New Mexico, Idaho. All right, everything that's been said so far. So yes, Alaska, lowest population density. All right. They're the populate. Yep, only about 733,000 people live there. But then look at the huge 570 square miles. Yeah, by far.
Why would you live
One of the big. I don't know. I've never been there. I know what I don't. Isn't there like no sunlight for like 6 months or something like that?
That's some depressing living.
I'd go there to visit. I don't know about the live. I'll have to decide that later. But okay, but I'd definitely go there to live, not or to go there to visit on vacation. All right, let's go back to population density and our Regents level question. We got Petri dish. One Petri dish has a bacteria of 40,000. Another Petri dish has a bacteria of 72,000. Which one has the highest population density? Do we have predictions before we calculate it? Okay, I guess we're calculating it then. Let's go dish A first. To calculate it, we take its bacteria population, 40,000. Over area. Hey, what's the shape now? It's a circle. So the first time we've done this today, I want to do pi r squared. We just spent a month doing this. 51 the r, the radius length. No, that's the what of the petri dish. Diameter, cut it in half. So when we do pi r squared, you don't want to use 51, you want to use half of it, 25 and a half squared. Okay, 25 and a half squared. And then 37.5 for the radius of dish B. Pretty close. Bacteria per square millimeter. Pretty close. But by about three bacteria, dish A's got the higher population density by about 3 bacteria. Homework. First part of the homework is the next page. There's 2 population density questions on the next page. The rest come from your textbook. You all have graph paper, so you can graph the one that needs to be graphed. But remember, don't forget about the 2 problems in your packet that you can start right now if you want to work right up to the bell.